Welcome to Math Classes. We'll see some more integration problems, JEE PYQs. This is part 7 of the video. You can see my playlist for the other videos. In this video, we'll mainly see one new concept, which is Riemann Sum Identification. This is very important for the integration and sequence combination. Okay, so let's get into the problems. Yes. Let f is the function defined as R to R. From R to R be defined as f of x equal to a e to the power of 2x plus b e to the power of x plus cx. If f of 0 equal to -1, f dash of log 2 is 21, and integration of 0 to log 4 f of x minus cx dx equal to 39 by 2, then what is the value of absolute a plus b plus c? Okay, so look at this function is defined. All we need to do is we need to find out these variable values a, b, c. If you can find out with these two, then we don't require integration. So let's see that first. We might require the integration. That's why they gave, right? So this is my f of x. If I substitute 0, f of 0 is nothing but a plus b, which is equal to -1. One equation we got. Okay, f dash x is 2a e to the power of 2x plus b e to the power of x plus c. So f dash of log 2 is nothing but 8a plus 2b plus c equal to 21. Now you have three variables and two equations, so this is not enough to actually solve the problem, right? So we need the third equation to be solved, right? That is integration. So integration from 0 to log 4 of f of x minus cx dx equal to, I can write this as integration from 0 to log 4 of a e to the power of 2x plus b e to the power of x dx. Okay, so this is a very simple integration. Okay, the solution is a e to the power of 2x by 2 plus b e to the power of x, and the limits are from 0 to log 4. You apply the limits, you get another equation. Okay, that is 15a plus 6b equal to 39. Okay, this is my third equation, right? So you have three variables, three equations. You can solve them directly, right? So you can solve it yourself. You will get a equal to 5, b equal to -6, and c equal to -7. Okay, once you have these three values, absolute a plus b plus c is nothing but 8. That's the answer. Okay, next. The value of limit n tends to infinity is sigma k equal to 1 to n cube by n square plus k square into n square plus 3k square is. Okay, so this is the problem where I said understanding the relation between series and integration. Okay, so since you see my integration classes or any integration lesson, when you start, everybody will tell integration is summation, correct? And we never got a problem where we actually deal with the summation, right? So if you see here, this is sigma is summation. Okay, now this sigma problem, we need to convert this into integration. Okay, this is where Riemann had proposed a way actually. So we need to understand this is not a complex thing. This is very simple, very easy to remember. Okay, so let's do this. Okay, so this is the given problem. Okay, if I simplify this, why I need to do this one is I need to make it look like f of x. Okay, the whole thing should look like f of x delta x. Okay, so limit n tends to infinity, sigma k equal to 1 to n. 1 by n is common. I am taking n square and n square out, which is n to the power of 4. So n cube by n to the power of 4 is 1 by n. Okay, and the numerator is 1 because n cube is gone, divided by 1 plus k by n whole square into 1 or 1 square plus 3 times k by n whole square. Okay, now it looks like k by n if I take it as x. Okay, k by n if I take it as x, this looks like 1 plus x square into 1 plus 3x square, and 1 by n is nothing but differentiation of k by n. Okay, so if I take x as k by n, dx is nothing but 1 by n dk, correct? So this now can be converted easily into a integration problem. For this one, Riemann proposed a sum identification. Okay, so that is nothing but if you have a limit n tends to infinity k equal to 1 to n f of x delta x, then you can write this as integration from a to b f of x dx. Okay, how to get a and b values, I'll show you with this example only. Okay, so we know that in our case x is nothing but k by n, and we know that k is running from 1 to n. K is running from 1 to n inclusive. Okay, so if you take k equal to 1, you get lower limit, correct? So a is nothing but 1 by n, and n is going to infinity. So 1 by infinity is 0, and b is upper limit, which is equal to n by n, because k is running from 1 to n. So n by n is 1, we already know. We don't need to see this 1 by infinity forms. Okay. So b is 1. So most of these problems where you apply Riemann sum identification, most of them will come to 0 to 1, but don't take it for granted. Okay. You need to calculate your limits. Okay. If it is in this form, yes, yeah, 0 to 1 you can directly put. Okay. So now this problem is the integration problem, integration from 0 to 1 of dx by 1 plus x square into 1 plus 3x square. This is very simple. You just apply partial fractions and find out individual ones, right? So that is nothing but 3 by 2, 1 plus 3x square minus 1 by 2 divided by 1 plus x square. Okay, so if I integrate this now, it will become integration is 3 by 2 of integration from 0 to 1 of dx by 1 plus 3x square minus 1 by 2 integration of 0 to 1 dx by 1 plus x square. Okay, this is in the form of tan inverse, correct? Very simple. So 3 by 2, 1 by root 3, tan inverse of root 3x by 1 minus, and limits are here. Okay, 0 to 1 minus half of tan inverse of x, limits are from 0 to 1. Apply carefully the limits, you will get the answer. All are the correct answers only. Only thing is you need to check your multiple choice which one it is following. Okay, normally we don't leave third in the denominator. Okay, so this one yeah, I mean we should actually move this to up and keep it. Actually we should call it actually pi root 3 4 minus root 3 into 24 divided by 24. Okay, but in the options it is in this form. Okay, so 13 pi by 8 times 4 root 3 plus 3. Okay, once you see this value you can easily convert into this value. Okay, so this is the answer. Next, that function is defined from minus pi by 2 to pi by 2. Okay, to r, okay, be a differential function such that f of 0 equal to half if the limit extends to 0, x times integration from 0 to x of f of t dt divided by e to the power of x square minus 1 equal to alpha, then what is the 8 alpha square? So whenever you see something like this, right, limit applied and then we need to differentiate the integration, then you should remember the Newton-Leibniz formula, right? So we'll apply that one. Okay, in this case, can I simply, if I substitute x equal to 0, what happens? This is 0 by 1 minus 1, which is 0, 0 by 0 form. So if I differentiate, I should get the answer. But if you look at the denominator differentiation is very complex. This will never end actually because it is e to the power of x square. Always you will have some term. That is fine. But one time you can differentiate this. But what about next time? You don't have any information about what is f and you don't have any value for f dash. So that's not possible. So we have to stop at f only, right? You cannot go further integration, correct? So which means we need to simplify this limit first. Okay, whenever you see this one in limits, okay, e to the power of x minus 1 by x is limit extends to 0 is 1. So in this case also we should convert that into this form. Okay, so how to do that? I will write this given limit as limit extends to 0 x integration from 0 to x of f of t dt divided by e to the power of x square minus 1 divided by x square into x square. I wrote it. Okay, now I know that this limit is 1, correct? So simply x by x square is 1 by x. So I will divide this into numerator, limit extends to 0 integration from 0 to x of f of t dt divided by x. Okay, this limit is applied to this one. Okay, and divided by limit extends to 0 e to the power of x square minus 1 by x square. This is 1. Okay, and whole this one is alpha. So now this is simple. This is standard limit, which is, sorry, not integration, standard limit actually. Okay, so which is 1. So my alpha is nothing but limit extends to 0 integration from 0 to x of f of t dt divided by x. Now if I substitute x equal to 0, this is 0, 0 by 0. So I need to apply L'Hospital rule, correct? So L'Hospital rule means you have to differentiate numerator. That means I need to apply Newton-Leibniz formula, right, which is nothing but f of x minus f of 0. F of 0 will go off in the differentiation as 0, so f of x. So this is nothing but f of x divided by 1. This differentiation is 1. Now if I apply limit, x tends to 0, okay, this is nothing but f of 0, that is half. So alpha is half. So my 8 alpha square is 2. That's the answer. Next. Limit extends to pi by 2, integration from x cube to pi by 2 whole cube, cos of t to the power of 1 by 3 dt divided by x minus pi by 2 whole square. looking at this very clearly, we can tell we have to apply Newton-Leibniz formula, correct? So that's very simple. Now let's see how to do this. Okay, if I substitute first, okay, limit if x equal to pi by 2, if I substitute, integration is same limit, so it will be 0, and here also 0 by 0 form, so I have to differentiate, correct? So which means I need to apply Newton-Leibniz theorem, right? Formula, which is nothing but I have to take this cos t to the power of 1 by 3 and apply the limits. Okay, so first one is cos pi by 2 into differentiation of pi by 2 is 0, so this first term is 0 minus cos of x, okay, x cube whole to the power of 1 by 3 is x, and x cube differentiation is 3x square, divided by denominator differentiation is 2 times x minus pi by 2. Okay, now if I substitute pi by 2, okay, if I substitute pi by 2 here, this is 0 again, this is also 0, so you need to apply the L'Hospital rule once again, correct? So that is, if I differentiate numerator, I get minus 6x cos x plus 3x square sin x divided by 2. Now if I apply x equal to pi by 2, what I will get is 3 pi square by 4 into 2, that is 8. So answer is 3 pi square by 8. This is a simple straightforward question, right? Next. The value of integration from minus pi by 2 to pi by 2, x square cos x by 1 plus pi to the power of x plus 1 plus sin x square divided by 1 plus e to the power of sin x to the power of 2003 dx equal to pi by 4 into pi plus a minus 2, then what is a? Looking at this, we can clearly tell this is very tricky question, right? Just as tricky question. It looks very easy that this denominator will go off, right? So we just need to apply that powerful rule, which I always tell, right? Powerful in definite integrals rule. Then this denominator will go off. We have done similar problems before, so you should remember at what point this is useful, correct? So I'll use this integration from b to a of f of x dx is nothing but integration from b to a of f of a plus b minus x dx. Okay, this is very, very powerful definite integrals formula. Okay, now if I apply x equal to pi plus 2 minus pi by 2 minus x, which is x equal to minus x, if I substitute, what happens is integration will become I, same I, minus pi by 2 to pi by 2 of x square cos x, no change here, divided by 1 plus pi to the power of minus x plus 1 plus sin square x, no change here, divided by 1 plus e to the power of minus sin x to the power of 2023, because this is odd, this will become minus, so minus will come front, okay, dx. Now if I add these two, basically this denominator will go off, correct? So if I add these two, 2i is nothing but integration from minus pi by 2 to pi by 2 of x square cos x, which is common, then 1 by 1 plus pi to the power of x plus 1 by 1 plus pi to the power of minus x. Okay, if I write this as 1 by pi to the power of x, this whole thing will become 1. Similarly here, this whole thing become, second part whole thing will become 1, correct? So I am left with a simple integration now. Okay, 2i equal to integration from minus pi by 2 to pi by 2 of x square cos x plus 1 plus sin square x. Okay, x square cos x plus 1 plus sin square x dx. Okay, because this is minus pi by 2 to pi by 2, I can make it 2 times integration from 0 to pi by 2 of this x square cos x plus 1 plus sin square x dx, correct? Now this is nothing but I, right? 2i equal to 2 times integration, so that means this is I. Now out of this part is very simple, right? One is simple integration of 1 sin square x, I can write in terms of cos 2x, so this is also simple. Only thing is here I need to apply product rule, correct? So this is what it is, integration from 0 to pi by 2 of x square cos x dx. This I need to find out from product rule, and this is straightforward. Okay, so let's do that. Okay, so I will call this one as I1. So I1 is nothing but x square cos x integration from 0 to pi by 2. Product rule, if I apply, f of x is x square, g of x is cos x. So this will become x square sin x from limits 0 to pi by 2 minus integration of 0 to pi by 2 of x square integration, which is 2x. Okay, and integration of cos x is sin x dx. Now again I have to apply product rule on this one, second integration, correct? So first one, if I apply limits, it will become pi square by 4 minus 1, and second one pi square by 4, okay, then minus 2 times, okay, there is a 2 here, so 2 times. And if I apply product rule on x sin x, what I'll get is minus x cos x with limits plus integration from 0 to pi by 2 cos x dx, which is sin x, we know it, right? So this is nothing but this one, right? And this limits, if I apply, I'll get 0 only. Okay. So finally my I1 is nothing but pi square by 4 minus 2. Now I have my I1. So my whole integration is I is nothing but pi square by 4 minus 2 plus, okay, 1 plus 1 by 2, which is 3 by 2. So 3 by 2x limits 0 to pi by 2 minus, okay, minus 1 by 2 cos 2x integration, which is sin 2x by 4. Correct. So 1 by 4 sin 2x limits from 0 to pi by 2. If I apply limits carefully, what I will get is this value, pi square by 4 minus 2 plus 3 pi by 4, which I can write this in the given form, that is pi by 4 plus pi plus 3 minus 2. So my A is 3. That's the answer. Okay. Next. For A is between 0 and 1, the value of integration from 0 to pi of dx by 1 minus 2a cos x plus a square. Okay. So this is also a straightforward thing. Only thing is, first thing is you apply the integration, definite integration rule, pi plus 0 minus x. If you apply, okay, cos will change to anything. You can check that, right? So I is nothing but this one. If I substitute x equal to pi minus x, it will become dx divided by 1 minus 2a cos pi minus x plus a square, which is nothing but this minus has become plus. Okay, integration from 0 to pi dx by 1 plus 2a cos x plus a square. Now these two are i's, correct? Only thing is denominator is 1 plus a square. If I take 1 plus a square as a, capital A, or m, let's say, and this 2a cos x is n, this is m minus n into m plus n, correct? So if I add them, this is nothing but m square minus n square, and here 2m you will get. So you get 2 into 1 plus a square dx. Okay, you just add, this is fractions, right? 2 are fractions, so you add them, you will get this one. Okay, now this is a simpler one compared to the other one. Okay, because cos square x, I will take it common, it will become secant square, and secant square here, right? So integration is now 0 to pi of 1 plus a square into secant square x dx divided by 1 plus a square whole square into secant square x minus 4a square. Okay, this is, if I just expand secant square x as 1 plus tan square x, this is what it is, because I can take tan x as t, then it will become, this will become dt. Okay, rest all will be constants, right? Okay, now if you check, actually the problem here is, if you check limits, if I take tan x equal to t and check the limits, tan 0 is t is 0 and tan pi also 0, so it will become 0 to 0 actually. Sorry, not 1, it will become 0 to 0, actually not 1 to 1, 0 to pi limits will become 0 to 0. So you actually cannot do anything. So better you take it 2 times 0 to pi by 2, right? That is easier one. Okay, so you take the, split the integration from 0 to pi by 2 and pi by 2 to pi, so it will become 2 times basically. So integration is 2 times from integration from 0 to pi by 2 of 1 plus a square secant square x dx divided by 1 plus x square whole square into 1 plus tan square x minus 4a square. Now you take tan x as t. Okay, tan x as t, secant square x as dt. Now limits will change, 0 to pi will 0 to pi by 2, sorry, not, this is not pi, this is pi by 2. 0 to pi by 2 will become 0 to infinity. Okay, tan 0 is 0, tan pi by 2 is infinity. Okay, now integration is from 0 to pi by 0 to infinity of 2 times 1 plus a square dt divided by 1 plus a square whole square t square plus 1 minus a square whole square. It looks very big, but all are constants here actually, right? If you write it in simple term, if you write it in simple term, okay, this is nothing but integration of dx by a square plus b square x square, which is equal to 1 by ab tan inverse of x by a plus k. That's it, right? So this is just a tan inverse actually, right? Only thing is you are confused with such a big a square and b square terms. That's all. So you just apply the formula. This is nothing but I is equal to 2 times 1 plus a square divided by 1 minus a square into 1 plus a square tan inverse of x by 1 minus a square, and limits are from 0 to infinity. If you apply limits here, you will get, this is 2 by 1 minus a square into limits are, if you apply, you will get pi by 2 minus 0. So the answer is pi by 1 minus a square. This is the answer. Next. Now the same problem you can also try uh, in the initial videos. Actually, I told whenever you see sin x and cos x in the denominator, you have two ways to do, right? One is take the express cos x in terms of tan x is tan x by 2, right? You take tan x by 2 as t and then express cos x in terms of tan x by 2 and then solve it, okay? So that way also you can try it actually. So this is the given integration. You take tan x by 2 as t, and then 1 by 2 secant square x by 2 as dx as dt, correct? And then your dx is nothing but 2 dt by secant square x by 2, which is nothing but 1 plus t square. And cos x will become 1 minus t square by 1 plus t square. Now you substitute the values properly, you'll limits will change from 0 to pi to 0 to infinity directly, right? So this is your integration. Okay, now you simplify and solve it, you will get the same answer. Okay, so you can do this as a exercise. I don't want to solve the same thing again. Okay, here do it as your exercise. Next, if integration from 0 to 1 of dx divided by square root of 3 plus x plus square root of 1 plus x equal to a plus b root 2 plus c square root of 3, where a, b, c are real numbers, then what is the value of 2a plus 3b minus 4c? Okay, so one thing you remember, whenever you see square roots in the denominator, always you remember one statement. You don't like square roots in the denominator. First try to remove them. That will solve many problems actually. Okay, so in this case also we can do that. Eliminate the square roots from the denominator. So I'll call this 1 by square root of 3 plus x plus square root of 1 plus x as, if I multiply with the conjugate, this is what it is. Square root of 3 plus x minus square root of 1 plus x divided by 3 plus x minus 1 minus x. So I am left with square root of 3 plus x minus square root of 1 plus x divided by 2. Now this is a simple straightforward integration, correct? This is 3 plus x whole to the power of half minus 1 plus x whole to the power of half. So that will become 1 by 2 is as is, 1 by 2 is here, and 3 plus x whole to the power of 3 by 2 divided by 3 by 2, so it will become 2 by 3 minus 1 plus x whole to the power of 3 by 2 divided by 3 by 2, so it will become 2 by 3. Limits are from 0 to 1. Apply limits carefully, you will get the answer. The value is 3 minus 2 by 3 root 2 minus square root of 3, which is nothing but in the form of a plus b square root of 2 plus c square root of 3. So you compare the values, you will get a equal to 3, b equal to minus 2 by 3, c is minus 1. So your 2a plus 3b minus 4c is nothing but 8. That's the answer. Next. If a comma b be the orthocenter of the triangle whose vertices are 1 comma 2, 2 comma 3 and 3 comma 1, and I1 is given here integration and I2 is given here, then what is 36 I1 by I2? Okay, so look carefully. Actually, the only difference between these two integrals is this x term here. Okay, that means if you try to solve I1, you will get I2 as one of the term. Okay, so that's the trick here. Okay, so first thing is we need a comma b. So a comma b are the orthocenter of the triangle. So if I take orthocenter is lies on the perpendicular to the line passing through 1 comma 2 and 2 comma 3 and passing through 3 comma 1, correct? So if I take this slope, the orthocenter slope is perpendicular slope, okay, and pass through this one, correct? So I can construct the line equation very easily, right? So slope of the line passing through 1 comma 2, 2 comma 3 is 1, so perpendicular slope is minus 1. So orthogonal has a slope of minus 1 and passing through 3 comma 1, so equation is x plus y equal to 4. If I substitute a comma b, because a comma b is the orthocenter, this pass through this line, right? This is on this line only, so it will be a plus b equal to 4. Now you can actually solve a comma b with the, because you are given 3 points, you can solve it. That is not a big thing. But do you require here? Because we know that there is a powerful definite integral formula where you replace x with a plus b minus x, right? Then you see a different integral. Now I need a plus b minus x, which is nothing but 4 minus x, correct? So let's see that. Okay, let's take I1 and then see what happens. So this is my I1, integration from a to b x sine of 4x minus x square dx. If I substitute that, integration from a to b of a plus b minus x into sine of 4 times a plus b minus x minus of a plus b minus x whole square dx. Now this is nothing but 4. So my integration will become simple now. Integration 4 minus x into sine of 4 times 4 minus x minus 4 minus x whole square. You expand this carefully here. Okay, I did here. and then simplify, what you will get actually is very interesting. You will get integration from a to b of 4 minus x into sine of 4x minus x squared dx. Okay. Now, if I separate this 4 minus x into two integrals, this will become 4 times sine of 4x minus x squared dx and integral of x times sine of 4x minus x squared dx. Now, if you look at here, this is nothing but 4 times I1, 4 times I2, sorry. This is 4 times I2. So, my I1, this is I1. I1 is 4 times I2 minus I1, correct? I1 is 4 times I2 minus I1, which means 2I1 is 4I2, I1 by I2 is 2, 36 times I1 by I2 is 72. That's the answer. Okay, hope you understand this. Next. The value of e to the power of minus pi by 4 plus integration from 0 to pi by 4 of e to the power of minus x tan of 50x dx divided by integration from 0 to pi by 4 of e to the power of minus x into tan of 49x plus tan of 51x dx. Now, if you say it's trying to trick us actually, because if you see these integrations all are same, only thing tan power is different. Okay, otherwise integration is exactly same. So you take a general integration and solve it, probably you'll get the answer, right? So what is the general term here which I need to solve the integration? Okay, if I expand this given integration, it will become the denominator especially, it will become integration from 0 to pi by 4 of e to the power of minus x tan of 49x dx plus integration of e to the power of minus x tan of 51x dx. And you have integration of e to the power of minus x tan of 50x dx in the numerator, right? So I will call this of I of 50. So e to the power of minus pi by 4 plus I of 50 integration of this one divided by I of 49 plus I of 51, correct? So now simple, take I of n and then solve what happens. Okay, so I of n is nothing but integration from 0 to pi by 4 of e to the power of minus x tan to the power of nx dx. We have to apply product rule. I late trigonometry comes before exponential, so my f of x is trigonometric ratio, that is tan to the power of nx, and g of x is e to the power of minus x. So if I apply, I'll get tan to the power of nx into e to the power of minus x minus of e to the power of minus x, because this is the integration of e to the power of minus x. Limits are from 0 to pi by 4 minus integration from 0 to pi by 4 of n times tan to the power of n minus 1 x into secant square x. Okay, that's the differentiation of tan to the power of nx into minus e to the power of minus x dx. This is integration of e to the power of minus x, right? Now carefully you check this. Okay, secant square x, I can write it as 1 plus tan square x, correct? So I wrote it here. This one, if I apply limits, I'll get minus e to the power of minus pi by 4 plus integration from 0 to pi by 4 of n times tan to the power of n minus 1 x into 1 plus tan square x e to the power of minus x. Okay, this minus and this minus become plus here. Okay, so that's equal to e to the power of minus pi by 4 plus n times integration of 0 to pi by 4 of e to the power of minus x into tan to the power of n minus 1 x dx. Okay, 1 less power. Okay, plus n times integration from 0 to pi by 4 of e to the power of minus x into tan to the power of n plus 1 x dx. 1 more than tan to the power of nx, 1 less than tan to the power of nx, correct? So if you put it in general term, this is how it is looking. I of n is I of n plus e to the power of minus pi by 4 is nothing but n times I of n minus 1 plus I of n plus 1. Now if you take n as 50, this is what we are looking at, correct? Take n equal to 50, I of 50 equal to e to the power of minus pi by 4, which is equal to 50 times I of 49 plus I of 51. So you write in this form, correct? This is what we are looking, that is 50. That's the answer. N, basically n is the answer, so here it is 50. Next. Yeah, that's all. These are the collection of problems from JEE PYQs basically. Each one is different actually. That's why I like solving these one. With this, you will learn all the tricks and trades of integrations actually, or any chapter. Okay. If you really don't have too much time to prepare for JEE or any other engineering entrance exam, PYQs are the best. But solve as many as like 4 or 5 years PYQs you should solve in that case. Okay. Thank you. Keep doing maths.